Beyond Newton lies a universe far stranger than fiction. Teleportation, the idea of disappearing from one place and instantly reappearing somewhere else, has captivated human imagination for centuries. From Star Trek transporters to sci-fi dreams of instantaneous travel, we've always wondered, can we really teleport? But what if I told you that quantum physics has already made teleportation possible, just not in the way you expect? Stick around, because this is not science fiction. This is quantum teleportation, a phenomenon so strange it could reshape how we understand information, space, and the very fabric of reality. First, let's be clear. Quantum teleportation doesn't involve physically transporting matter. Instead, it's about transferring the state of a particle, the information that defines it, to another particle, possibly light years away. Here's how it works. You take two entangled particles. Let's call them Alice and Bob. Alice is with you on Earth. Bob is on Mars. You interact Alice with a third particle, say, Charlie, whose state you want to teleport. You perform a special quantum measurement on Alice and Charlie together. This destroys Charlie's state, but transfers it instantly to Bob on Mars. No physical particle moved, yet Charlie's state lives on, in Bob. That's quantum teleportation. The exact quantum state of one particle is transmitted, through entanglement, to another particle, without traveling the space in between. To truly understand quantum teleportation, we have to dive deeper into quantum entanglement. Entanglement is a bizarre phenomenon where two particles, no matter how far apart, share a connection so deep that the state of one instantly determines the state of the other. Einstein called it spooky action at a distance. He believed it was impossible, that there must be some hidden variables explaining it, but experiment after experiment proved otherwise. Here's the kicker. This spooky connection doesn't transmit classical information. It's not like texting across space, but it can transmit quantum information, the delicate, complex data that defines the exact behavior of particles. This is the secret to quantum teleportation. Quantum teleportation isn't just a theory. It's been demonstrated in labs around the world. 1997, scientists at the University of Innsbruck teleport a photon's quantum state across a short distance. 2012, teleportation occurs across 143 kilometers, between two Canary Islands. 2017, Chinese scientists teleport a photon's state to a satellite orbiting Earth, using entanglement and quantum channels, and it's getting more powerful. In 2020, a team at Fermilab achieved sustained high-fidelity quantum teleportation across 44 kilometers of fiber optic cable, laying the foundation for a quantum internet. Think about it, not just sending data, but transmitting quantum states perfectly preserved over vast distances. That's not just progress, that's revolution. So let's pause. What's the difference between what we're doing and sci-fi teleportation? In science fiction, teleportation means disassembling a person at the atomic level, transmitting that information, and rebuilding them elsewhere, molecule by molecule. But that's impossible. Why? Because in quantum mechanics, you can't perfectly copy an unknown quantum state. This is the no-cloning theorem. So we don't copy the quantum states. We destroy it at one location, and recreate it in another. This means, if we ever tried teleporting a human quantum mechanically, you'd be destroyed in one place, and rebuilt somewhere else. Would you still be you? Would it be teleportation, or death and rebirth? The real power of quantum teleportation isn't about sci-fi travel. It's about revolutionizing information. Imagine a quantum internet, where quantum bits, qubits, are transmitted instantly and securely through entangled networks. Secure communications that can't be hacked. Quantum computers speaking to each other across continents. Real-time quantum processing, enabling unimaginable simulations. Governments and companies like Google, IBM, and China's MISHIS satellite project are racing to build the first global quantum networks. Teleportation is no longer just a fantasy. It's becoming infrastructure. But it also raises new questions. What if quantum teleportation could one day bridge the gap between mind and machine? Could consciousness itself, if ever reducible to quantum states, be teleported? That's not just computing. That's the philosophy of identity. If you could teleport your quantum state to another body, would it still be you? Are you just the information in your brain, or something more? Something that can't be transferred? If we destroy your current state and recreate it elsewhere down to the atom, is that truly you, walking out the other side? Or have we just copied your essence and lost the original? Teleportation forces us to confront a haunting idea. What does it mean to be you? We can now send quantum information across the stars. entangle particles that never meet, teleport a ghost of reality itself. But in all this, we still don't know what consciousness is, whether identity survives transfer, or if there's something more, beyond equations, beyond particles, beyond teleportation. So the real question isn't, can we teleport? The real question is, what are we teleporting? And that is beyond teleportation, beyond science, beyond certainty. This is beyond Newton.